Hi everyone. So today we start module 10, which is about Kubernetes. And looking at this, it's like, wow, we already covered so much stuff. It was September, October, November. So it's been 3 months, pretty packed months with information. I hope your head is not exploding yet. With the amount of information you try to put there. So it is the last week, the last module we have. This one, Kubernetes. There is one more, Kserve, 11th one, which is optional. So if you don't feel like you have energy, you don't have room in your head to put yet another topic, then don't worry, it's optional. But if you like the Kubernetes chapter, the Kubernetes module, and you want to learn more about that, so then Kserve is like a good continuation of that. So Kserve makes it simpler to deploy things with Kubernetes. It's like similar to Flask and Bento, maybe. So, but now we are not talking about Kserve. We are talking about Kubernetes. So most of you hopefully finished week 9 with serverless by now. And in that week, we talked about Lambda. But week 10 is a totally different thing. So it's like the opposite of serverless. Kubernetes is the opposite of serverless. Here you have all this like pods, nodes, all this stuff that you will see in the course, in the module. So we will actually run things on machines, on computers. So this is not serverless, the opposite of serverless. And what we will do here is we will also take the closest classification model from deep learning model, and we will see how to serve it with TensorFlow serving. This is different from TensorFlow Lite. And we will first do this locally, and then we will deploy it with Kubernetes. So yeah, you see, the actual Kubernetes starts from here, and then at the end we will see how to do this in AWS. This is a great chapter. Actually, this was one of my favorite ones when I was writing a book and when I was preparing this video, because there are not so many. There are not so many resources about Kubernetes, especially using Kubernetes for data science, for machine learning. I hope it's not too difficult, and maybe by now, after seeing all that other stuff, it might be not as difficult for you, but it still could be tricky, right? So there are some like Kubernetes is not a simple thing. So don't don't go too hard on yourself if some things are not clear. Okay, that's it. So homework is already available. So Timur just made a few changes to the homework. So you can see the homework here. We try to make it a little bit more exciting than the one last year. So in the homework, you will also experiment a little bit with auto-scaling, which wasn't the case in the previous homework in the previous year. So we hope you enjoy it, and yeah, have fun. Apart from that, do I want to mention anything else? Yeah, I wanted also to talk about the competition. So this kitchenware classification. I already wrote that in the channel. So you see on the leaderboard, there is this score with ones, which could be demotivating for most of you. It would be very demotivating for me. That's why I think we will add, I'm actually working on this right now, on adding more data to the test data set. So you will need to rerun some of your code. But hopefully we will not have perfect scores. I spent a lot of time cleaning this data, preparing this data set. So maybe for the extra data set, I will not do so much cleaning. So it's more, let's say, dirty. So then getting the perfect score would be more difficult. Okay, that's the thing about the competition. It's really nice to see so many people actually trying to do this. And to be honest, I did not expect such a good score like this. When I saw this like 98 score, I was a bit surprised. But Yeah, we will also during December and January explore other ways to make it more interesting. So we'll also see how to add generated images to make the training better. And we'll also see how to use crowdsourcing probably for that. Okay, enough of that. Another thing. So I forgot to mention that we already covered serverless, but we didn't talk about Bento yet. So with Bento, you can also deploy your Bento to serverless, to AWS Lambda. So Tim and I are working on videos to show you how to use Bento with serverless and also how to use Bento with Kubernetes. So next week, by the end of this week, hopefully, at the beginning of next week, we will have 2 more videos. One showing how to use Bento with AWS Lambda, and then another one showing how to use Bento with Kubernetes. Or at the very least, if we will not have a chance to do a video, we maybe will do a live stream next week on Monday, like during office hours, where Tim will show you how to do this. Okay, let's see what are the questions. What function or library can I use to separate a set of images in training, validation, and test? Yeah, usually, well, probably you are not talking about you're talking about images. So the way I would do this, maybe there is a library for that. So the way I would do this is I would use a thing called glob. So this is in glob Python. And then I would use this glob function from Python to get all the files in your in the directory with images. So then you have a list of files, and then you can use something like train, test, split from scikit-learn to split it into 3 groups. And then each of these groups would be train, test, train, validation, and test. So this is how I would do this. So it's not a library. So you still will need to use, yeah, but it will be like 4 lines of code or something like that. So yeah, use glob and then train, test, split from scikit-learn, and then you'll be able to do this. And then of course that might not be enough, so you might also need to write a bunch of code, extra code, for putting this into directories, like we have in clothing classification. So in this clothing dataset, we already put I already put this dataset into 3 folders, and then so we have train, and then we have classes here. So you might also need to write some code for distributing all your files into different subfolders, which is also not a lot of code. Like, I don't know, 10 lines, maybe 12, give or take, maybe 20, I don't know, but it's not like it's not too awful. Maybe if some of you figures this out, you can post it in Slack, so then others can also use it. Okay, I hope I answered that. Is it possible to submit a competition entry as a capstone project? I'd love to enter a competition, but I'm afraid I won't have time for both. It is possible to use the competition as your capstone project, and I actually would like to encourage that. So please do that. One thing though, so in competition, you only train a model. You do not deploy the model. So that is something you will need to do extra for the capstone project. So yeah, you can spend a bit of time taking part in the competition, then you will have a model, and then you can just do the rest of the stuff, like deployment of that model for your capstone project. That is totally fine. Yeah, and also the competition will last for 2 months. So it's actually I wanted to open it from 1st of December, but somehow on Kaggle I didn't see how to open it to keep it close and open it on the 1st of December, so it got opened earlier. But yeah, so official date would be like 1st of December, and then from that it's 2 months. So maybe during these 2 months you will be able to find a bit of time. And yeah, please use it as your capstone project. What is the difference between CMD and entry point? Okay, what I will do is I will copy this and put to Google and see what it answers. Mm. Yeah, I don't know. Is it good enough, or you want to know more about that? But yeah, I usually go with entry point, and I think entry point is so in Lambda we use CMD because entry point is already specified in the base Docker image, and then using CMD you kind of can override the entry point, but only partly. It's like a part of entry point is CMD. As far as I remember, that's the main difference between them. Yeah, look it up. So I don't remember too. Can TensorFlow Lite be used in a Lambda function without a Docker image, only function serverless? It can be. Docker makes it a lot easier to do this, but it doesn't have to be Docker. With Lambda, yeah, you will need to prepare a zip archive that has everything you need for deploying a Lambda function. So you will need to put like all your dependencies like NumPy, Pillow, and TensorFlow Lite inside a zip archive. And you package everything in the zip archive, you put the zip archive to S3, and then you tell Lambda, okay, this is where my files are, get them. You need to be careful when you prepare the zip archive. So let's say if you use macOS and you're on M1 chip, then most likely the zip archive you prepare on your Mac will not work on Lambda. So you probably will need to do this inside Docker. Then inside Docker, you prepare a zip archive, and then you use the zip archive to upload this to AWS. If what I'm saying makes no sense for you, and it probably does not, because it's the first if it's the first time you use Lambda, you can just again Google AWS Lambda prepare a zip file with dependencies. So what do we see here? I'm not sure docs from AWS are great, so there's probably deploy AWS Lambda, Python. Yeah, that's important stuff. Yeah, I'm sure if you try this. So let's see, pip install. Yeah, I think this is right. So this is what we need. So when you do pip install -r requirements, so you put all the things in the requirements, and -t is the folder where it should install all the requirements. So I would actually put it into a separate folder called build, for example, and then it would install all the dependencies to this build folder, and then you go to build, and then you do zip to package everything, and then this is your zip file. And yeah, that's what you need to do. So glad we talked about that. So if it's not clear, if you're stuck, let's talk about this in Slack. How scaling may be implemented. Several servers, but also with several GPUs, batch inference. Okay, when it comes to scaling, so for example, when we talk about AWS Lambda, you don't need to worry about that. So Lambda, when it gets a lot of traffic, a lot of requests, and one Lambda cannot handle them, it automatically starts another Lambda function in parallel. So then another instance of a Lambda function. So for you, you don't need to worry about any of that. So Lambda is doing its own thing in the background. But as a result, what you get is it scales, it can handle more traffic. If you want to maybe have control over this, if you want to scale it yourself up and down, then in Kubernetes, there is this auto-scaling group. And you will see in the homework, in the Kubernetes homework, you will see how to actually do this. And also in module 5, when we talked about Elastic Beanstalk. Elastic Beanstalk can also automatically scale. So when it sees a lot of requests coming in, then it creates another instance, and then there is Elastic. How do you call it? Elastic, like basically load balancer. Yeah, I think it's called Elastic Load Balancer. Yeah, which forwards the request to multiple instances. Yeah, and then when it comes to GPUs, so in the course, we do not show how to use GPUs with Kubernetes. But if you Google, you will find you probably will need to look something like EKS GPUs, something like that. And yeah, here you will see how to add nodes with GPUs to your Kubernetes cluster, to EKS, and then based on that, yeah, you can scale, you can create more machines with GPUs if you need that, of course. And a batch inference. So what we talked about here is what I call online inference. So here in this course, we only covered online inference. And by online here, I mean we create a web service, and it's like an API, and you get the request, the service processes this request and replies with a prediction, a response, right? So this is what I called online or web server. There is another one, which is called offline. And this is what batch inference is usually. So, well, there is also what we saw in Bento. In Bento, there is a different kind of batching. So in Bento, it's still online. It just takes all the requests, puts them together in a batch, and then it's still web service. There is another way of serving, which I usually call batch serving or offline serving, is when we have all the data in our, let's say, S3 location or somewhere, and then we just load this data with something like pandas, we apply the model, and we save the predictions. So that's also an option if your use case allows it. And if you want to learn more about that, then we actually discuss this topic in more details in MLOps Zoomcamp. There is a module about deployment, this one. And here we talk about three ways of deploying. So web service, the one we used in that course, in this course, in ML Zoomcamp. Then streaming. This is when you have like stream of data and you react to events in that stream. And then the third one is batching. So if you are interested in learning more about deployment, definitely check MLOps Zoomcamp. What's the difference between Docker and Kubernetes? So Docker allows you to run a Docker image, so a set of prepared instructions. So this is what you put inside a Docker file. And then like when you do Docker build, Docker takes a Docker file and then creates a Docker image, and then you can run this image. You can run this image with Docker locally, and that's fine. But what Kubernetes is doing, it allows you to run many different Docker images. So Kubernetes is a container orchestration platform. So it allows you to take all these Docker images that you built on your local machine with Docker, and it allows them to execute in somewhere in a cluster, right? So it doesn't have to be on your computer. And then it automatically can provision more machines if you're running out of machines and all that. So it's like in a way, it's not 100% correct what I will say, but like you can think about this as Kubernetes orchestrates Docker images. So you have some images and then you just put them in Kubernetes, and Kubernetes figures out on which machine to run it, how many resources to give it. And then, yeah, it just runs them, orchestrates all these things. So you can think about this. Docker is for local use. Kubernetes is for deployment in the cloud, let's say. When to use BentoML instead of TensorFlow serving? Yeah, I wish Tim was here and would help me answer that, because I don't know. I assume if you wanted to use Bento, you would probably use TensorFlow Lite. You don't want to use like usual TensorFlow for the same reasons we talked about in the serverless chapter, in the serverless model, because it's simply too large. So then probably for Bento, you would use something like TensorFlow Lite, and it will still work. Yeah, and TensorFlow serving is, yeah, I don't know, like maybe another thing you can check. So in our channel, we had a talk from one of the Bento folks, which was This one. Yeah, building an ML service platform from ground up. So here, Sean talks about the differences between TensorFlow Serving and Bento. With TensorFlow Serving, it's good. It's quite optimized for deep learning. There are some problems. First of all, it's written in C++ and it expects your model in a certain format, like this saved model format. And then adding anything extra on top of that, like pre-processing, post-processing, becomes difficult because you will need to have like an extra step there. And Bento makes it easier, but again, I don't know. Like it's very difficult to give you a concrete recommendation without knowing what exactly you want to do. So it's case dependent. And if in your company you already use TensorFlow Serving, then maybe it makes sense to stick to that. But you know, if we have Tim next week on the office hours, maybe you can ask him that. He'll be a better person to answer. What is the difference between Streamlit and Gradio? So for those who don't know, Streamlit and Gradio are frameworks for creating user interface for machine learning. The main difference between them is Gradio is designed specifically for machine learning, while Streamlit is a general purpose user interface library in Python. So you can think of them as, I don't know, Flask and BentoML. Right? So with Flask, you can deploy a machine learning model, but you can deploy much, much more. While in BentoML, you can only deploy machine learning. So here it's the same. With Streamlit, you can build a machine learning interface for a machine learning model, but you can also build pretty much anything. With Gradio, it's only for machine learning. At least this is my understanding. I have used Streamlit. I have not extensively used Gradio. What would you advise to learn between TensorFlow and PyTorch? I don't know. Well, since we covered Keras in that course, I'm kind of biased because my advice would be learn Keras. But I do admit that more and more, so PyTorch becomes more and more popular. So probably if you look at the community size, you will find a lot more things in PyTorch than in TensorFlow. And also many new things, they first come in PyTorch, they are first implemented in PyTorch and then ported to TensorFlow. So for example, stable diffusion it was first implemented in PyTorch and then ported to TensorFlow. But at the end, it actually doesn't matter. They're quite similar, right? So if you now learn TensorFlow or Keras and then you join a company where they use PyTorch, you will just switch to PyTorch and the other way around. So I think on the higher level, it doesn't really matter. But if you want to go with popularity, then maybe PyTorch is more popular for modeling purposes. But if we talk about model deployment and model serving, I think PyTorch is still getting there. So TensorFlow, because of TensorFlow serving, and then there is also a thing called TensorFlow extended, and all that. It feels to me personally, it's not backed by any data. To me personally, it feels that TensorFlow is more mature when it comes to model deployment. I might be wrong, but this is my feeling. What team are you supporting in the football World Cup? So, yeah, for me, as a Russian citizen, it was actually surprising to learn that World Cup started because I simply didn't know about that until I guess last week when people all of a sudden started watching football. And then, yeah, I see that Ukraine doesn't play there. They have other problems right now, I suspect. So I would root for them if they played. I guess Poland. I know that they won recently a match against Saudi Arabia. So good job. I didn't watch it though. But if you ask me which team I would root for, then maybe Poland. Would you need machine learning for recommender systems? If yes, in which case? For pretty much every case, I guess. But yeah, you definitely need a machine learning for recommender systems. Maybe for a start, if you're just starting with a recommendation system, for your platform, then maybe there are simple things that you could do, like, I don't know, seeing what is the most popular thing in a certain age group, or what is the most popular thing in a certain category, and then recommending that. But quite quickly you will realize that you need something more substantial, let's say, and then there is no way to do it without machine learning. So you will have to use machine learning. So yeah, the answer is for every case. If I call a full stack data scientist, if I call someone a full stack data scientist with machine learning, data science, and data engineering knowledge, does it mean you want to become a full stack data scientist? What should I learn after ML Zoomcamp? Well, glad you asked. We have data engineering Zoomcamp, which starts in January, and we have MLOps Zoomcamp, which starts in May. The only thing that is missing here to become a full stack data scientist is the business understanding part. So remember when we talked about the process, CRISP-DM process, the first part was business understanding. So this is business domain knowledge, things like that. So the only thing that is missing to become a full stack data scientist is picking up this part. And then for that, I don't know what's the best way to learn it, apart from just joining a company and then talking to stakeholders, to the users of your model, and trying to understand more and more from them. And I do recommend doing this. But let's say if you don't work yet and you want to be a generalist, taking all these 3 courses is fine. You don't have to do everything there. So for example, in the data engineering course, maybe data warehousing could be like it's not as important for data scientists as for data engineers. So maybe you can skip that part. But chances are that as a data scientist, you will need to work with data warehouses too. So you might as well just watch the whole thing. What is the difference between epochs and iterations? So one epoch consists of multiple iterations. So remember in the code, let me maybe just open this and go to deep learning. And I will open a notebook. Okay, what's happening? Why it's not moving? No, my computer froze. So maybe it's too much stuff here. I hope you can it's still being transmitted. So let me check it on my phone. Oh, cool. I'm back. And I just realized that I don't have the stream open on my phone. So let me open it just in case, just to make sure I don't miss anything. Yeah, there are quite a few good questions that I want to answer that I want to answer too. Okay, so let me see where we start training a model. So this thing, batch size, right? So when we specify batch size, it means that we take our entire data set and we chunk this data set into batches of 32 images in this. All right. And when we, it's actually called a step, not an iteration. Yeah, then each step would be fitting a model on that batch specifically. And when you go over the entire set of chunks, then you finish your epoch, usually. Usually an epoch is going over the entire data set once. It's not strictly correct. You can define epoch differently. You can define epoch as 100 steps or 1000 steps, like up to you. But usually in practice, you say that one epoch for me is one iteration over the entire data set. So I guess here, when I say iteration epoch, to me, it seems like I can use them interchangeably. Yeah, but the difference between epoch and step is what I just described. I guess. Maybe if you find a different definition, please share it in Slack. What's your say on the future of Google Vertex AI and Dataform? Okay, what is Dataform? Manage data pipelines in BigQuery. Yeah, well, the page looks good, but apart from that, I cannot tell you more. Future of Google Vertex AI. Well, Google Vertex AI seems quite cool, so it simplifies many things. Yeah, like it has the future, but also I haven't used it a lot, but I can compare it with SageMaker. It's a similar thing on AWS. So with SageMaker, you can start using machine learning quite quickly, but then at some point it becomes restrictive, right? And then like there is only a certain way of doing things, and yeah, over time, so I use SageMaker a lot, and then over time I realized that I like a lot more the approach with Flask and Kubernetes, for example. But yeah, they look quite good, and I think it's worth learning them. Like if you want to do things fast, why not? For the capstone projects, can we use new models, for example, for object detection? Yes, by all means you can, but please make sure you document everything in the README file. You need to assume that people who will review your projects do not know anything about object detection, which will probably be the case because we didn't cover it. So you will need to describe all of that in the README. Like what is object detection? What are you doing exactly? Like what is the function? What is the metric you use for evaluating? Like how it works? So then people who look at your project, they will understand what's happening there. So you'll need to put more effort in documentation, but it's actually a good thing because your reviewers will also learn something new. So if you feel like you can do that, then by all means do that. Last 5 weeks of ML Zoomcamp, including the midterm project and last two homeworks. You lost last 5 weeks, but I'm catching up. Isn't fine if I do both capstone projects. Yes, that's the main reason we have two capstone projects, is for those who are catching up to still be able to get a certificate. Because now that there are holidays like Christmas holidays and then January holidays, like in some countries, like for example, in Russia, people usually take holidays not during Christmas, not during the end of December, but at the beginning of January. So no matter in which part of the world you are in, you still have like 1 month to catch up this month and then start working on capstone. And actually, now I realize that capstone starts quite soon, right? But for the capstone one, you only need first, let's say, 6 weeks. Then you can finish this project, and then you can, during the holidays, you can watch, I don't know, Kubernetes, neural networks, and so on, if you want, and then you can do capstone too. That's probably better. But yeah, it's fine. You should do too. What is the general points between computer vision and NLP? I don't think I understand the question. What do you mean by general points? Like, what are the similarities between them? Like for NLP, you can use some of the ideas from computer vision. For example, convolutional neural networks work for NLP too. But that's pretty much the extent of what I know about that. So I don't know much about NLP, to be honest, only basics. Like, I don't know, embeddings. So I don't know how to answer that question. Is Julia the future of data science? Probably no. I don't think so, but maybe yes. I don't know. Let's see in 10 years. When will the capstone project start? Today? No. Yeah, so it was today, but I changed it a little bit. So now let me go to the updated deadline calendar. And yeah. Here it is. So you see that the capstone project starts next week. And then for the evaluation, we give you a lot of time. So during this time, depending on when you take your vacation, so you take your vacation, you come back from the vacation, then you'll have some time to evaluate the project. So there will be some time to do evaluation. And then, yeah, the capstone project starts next week. I think what happened is when we added BentoML here, it kind of messed up with the whole schedule. The idea was to finish everything by Christmas. But yeah, like unfortunately, we won't be able to finish everything by Christmas, which means that yeah, probably if you do midterm project 1 and 2, like you can get your certificate somewhere here, or maybe at the end of January. I don't know. Let's see. Probably it will be easier to just give certificates at the end of January. Yeah. But like let's say if you finish everything by the new year, then you're free to start the, like, I don't know, just forget, stop taking the course, because I know it was very difficult, time consuming, but you might as well just, finish everything and start the data engineering course, or enjoy your life, or I don't know, many things. Yeah, we will also have an article which starts pretty soon. So probably the next office hours, I should talk more about that. Okay, what is your definition of a data scientist, and what would you advise between that and ML engineer or data engineer salary-wise? So salary-wise, I don't think it matters. Like all get good salaries. Regarding the difference, so there is an article in Data Talks Club, which is called Roles in a Data Team, which describes all possible roles and what exactly people in the team do. So there is data scientist, data engineer, and machine learning engineer. So you can go through this article and see the main difference. But maybe I can just quickly tell you. So data scientist is somebody who is working on modeling. So this is the first 4 modules, and then trees, and then deep learning. So if you focus on that and you know a bit of deployment, then you're good to go for data science. Machine learning engineer focuses more on engineering. So ML engineer should know some machine learning, not to the same extent as data scientists, but they still should know some machine learning, and they focus more on deployment. Right? Do we have, yeah, machine learning engineers? So usually the way it happens is both data scientists and machine learning work together on training a model, and then they both work on deployment. But in the first case, data scientist kind of is the expert on modeling, and then machine learning engineer is the expert on deployment. But typically, both of them should work together. And then when it comes to a data engineer, this is a person who helps them, or not helps, but prepares the data for them, or maybe not for them, but with them together, right? Because without, let's say, without a data scientist in this process, it will take a lot more time. So it's best when both data engineer and data scientists work on this together, and then data engineer explains what's the best way of doing what is needed for a machine learning project. So please go through this article. Hopefully it will answer all your questions. What are LSTM, RNN, and transformers? So I'll show you a trick. You can thank me later. So you take this question, you go to your favorite search engine, you put this to search, and you see the answers. Yeah, you're welcome. But honestly, I don't know how to. I don't know much about these things, and I know a little bit. But first of all, I might tell you something that does not make any sense, so I will not even attempt. And yeah, I'm not really an expert in NLP. And then the second, yeah, it's Googleable. You can find a lot of good resources. And then maybe I will show you one good resource, which is CS2, this one, 244N, which is natural language processing with deep learning, which talks about all these things. So do we have syllabus here? Schedule. Yeah. So word vectors, recurrent neural networks. So this is RNNs. Yeah, attention. So like, go through this thing if you're interested in learning more about that. Can you suggest a book about Kubernetes? I haven't read that one, but I heard it's good. It's called Learn Kubernetes in a Month of Lunches. So I heard that this is a good book. I have not tried it, but my understanding is that each day they give you a small chunk to implement, and then you implement this, and then you learn Kubernetes this way. How relevant do you think books are when everything changes so fast in the tech world? Well, I'll tell you a story about my book. So in the book that I wrote, Machine Learning Bootcamp, I thought it's a good idea to include a chapter about TensorFlow's Kubeflow serving. So I did that. It was actually at the end, so like I wanted to write a chapter only about Kubernetes, but then I thought, oh, it could be a good idea to also talk about Kubeflow serving. So then I included that, and then it took a couple of months for the book to go to production, meaning like, I don't know, they turned all these documents with chapters into a book. And then by the time the book was published, Kubeflow serving no longer existed because it got renamed to Kserve, and most of the stuff I was talking about in the book no longer worked. So yeah, books become pretty like books on new technologies become pretty like not irrelevant. I'm trying to maybe not obsolete, but maybe slightly outdated. So the last part of chapter 10 in my book is outdated now. So you can only use it for, I don't know, this old version of Kubeflow serving. And then the same with even this course, right? So we did a course, we did this Kserve module, and then by the time it finished, there was a new version, and then something stopped working there. So we needed to update that, and I wanted to thank Max Payne. I know it's not his real name, but he was very helpful preparing things, and then he left a few like notes there. So thanks a lot. And because of these notes, now it's actually up to date. The video might not be, but look at the notes. And yeah, I recently checked it and it's still working. Yeah, they do become outdated, but the rest of the stuff I put in the book is actually not outdated. The Kubernetes one still works. The Flask one still works. Maybe the version of Python we used, was it 3.7? I think in the book. Yeah, I wouldn't use it now. I would use 3.9, but most of the concepts are fine. So yeah, some things change, but not so fast. Some things change fast. And there are books like, for example, this Elements of Statistical Learning. Even though it's pretty old, most of the content, if not everything, is still relevant. But because it's theory maybe doesn't change. Fundamentals maybe don't change as fast as new technologies. Then there is also a nice question in live chat. On a scale from 1 to 10, how weird is it to have a Zoom call where you're the only one with a camera? It's super weird. I got used to this, but the first time I did it, it was super weird. So yeah, it's really strange. And on a scale from 1 to 10, I don't know, 8 maybe? Yeah, it's much more interactive or less weird when there is somebody on the other end of the Zoom call, but I know that you're actually listening there. I just don't see you. which makes it maybe a little bit less weird. Okay. I think we don't have any questions. I managed to answer all of them. Yeah, so with that, we will finish today, wrap it up. Again, thanks a lot for being here, for asking awesome questions. I hope you're enjoying the course. And again, as usual, if you have any troubles, write us in Slack and we will be happy to help you. And enjoy the capstone project too. And I think that's it from me. Have a great rest of your day and have a great rest of your week. Goodbye.